Hello, geometry. Welcome back. We're going to go ahead and do 1.3 today, rays, rays, segments, and distance. I'm going to set this up a bit differently. So what you can do for, again, these notes is I'm going to make what you see right now available on Google Classroom. Okay, so it's less writing for you, and you can kind of take your time and maybe listen a bit more. So these notes, again, that I'm going to do will be available for you to print out and then kind of go along with me as we kind of complete these together, okay? Or you can do them the traditional way, the way you did it last week, and just write everything out if you choose to do so. It's entirely up to you. I think most of you will print it out and do it along with me the way it's set up right now, okay? So let's go ahead and start with some vocab, and then we'll kind of work our way down and start applying it in bits and pieces, okay? Let's start with array, okay? Array is a part of a line that has one endpoint, okay, and continues forever in one direction. Okay, so it's like a hybrid between a segment and a line, right? There's going to be one endpoint, right? And the other portion, or the other half, is going in the other direction forever, okay? So here's my picture. We can say that that's point A. Here's point B, okay? Now, as far as notation goes, again, how would you refer this? Well, you would simply say ray AB using this notation, okay? If you said that this was BA, you'd actually be wrong, okay? This is the correct notation. This is the wrong notation because you have to start with your endpoint. Okay, you have to start with your endpoint. Okay, to bisect is to divide into two equal or two congruent parts. Okay, again, you can think of many examples. However, again, to bisect would be essentially, let's make these endpoints. So I know I'm cutting this line segment in half, and this portion is equal to this portion, okay? Segment bisector, again, we're just getting a bit more specific. That's a point, ray, line, or segment that divides a line segment into, again, two congruent parts, okay? You can use this same example for right here. Okay, again, you're cutting a segment into two congruent parts. Okay, opposite rays. Opposite rays are two rays that share the same endpoint. Okay, that go in opposite directions and form a line. Okay, again, let's go ahead and draw this out so we can see an example. Okay, let's call this B, point B. Let's go ahead and call this A. Let's go ahead and call this C. Okay, so what I have here is, again, a line, but I also have two opposite rays. Okay, for instance, we can say, hey, BA or ray BA is one half of this line, or we can say the other ray that's included is BC, okay? So those are two opposite rays that form a line. All right, to be congruent, again, I've used that word already a couple times, but it's two objects that have the same size and shape. If they have the same size and shape, they are congruent, okay? Again, in terms of segments, we're gonna compare the lengths. Okay. So, for instance, if I have segment AB, and that, in this case, this would be, let's say, 4 centimeters, and I have segment CD, and that is also 4 centimeters. Okay. What I could say about this is essentially AB, again, segment AB is congruent with segment CD. Right? All right. A midpoint of the segment is a midpoint divides a segment into 2 congruent segments. Okay. Again, a quick example of that would be, let's say I have a line segment. Okay. Let's call this A, and let's call this B. Let's say this line segment is about 8 centimeters long. Again, my midpoints of that would split that in half. We would call X the midpoint. Okay? So in this case, I would have, again, 4 here and 4 here, where AX, base line segment AX, is equal to line segment XB. Okay? X serves as my midpoint, my halfway mark. Okay? Where it divides the line segment into 2 congruent parts. All right, the next thing we're going to learn is segment addition postulate. Okay? That is, if 3 points A, B, and C are collinear, again, we should be familiar with what collinear means. That is on the same line, and B is between A and C. Okay? Then AB plus BC is equal to AC. Okay? Again, what that means is, let's take AB. Okay? Let's also take BC. That would, again, AB, so my blue line plus my red line would ultimately be equal to the whole thing, which is, again, a pretty easy phenomenon or idea to comprehend. Okay? That is segment addition postulate. All right, so our first example, okay, it says DE is equal to 6. Okay, let's go ahead and label that. EF in this case is equal to 13. What it's asking for is DF, which is the whole thing. Okay? Well, DE is 6, EF is 13, DF ultimately would have to be equal to 19. Okay? Just simply by using segment addition postulate. All right, next example, we've got DE, which is equal to X plus 3. So again, I'm going to go ahead and label that in. X plus 3. EF, on the other hand, is 2X minus 6. And the whole thing, again, DF is equal to 12. Okay? Again, using segment addition postulate, I know that this whole thing is equal to 12. Okay? Again, so this length plus this length is equal to 12. Right? So that's exactly what I'm going to do. So I have X plus 3 plus 2X minus 6 is equal to 12. I'm going to go ahead and combine like terms here and here. Okay, I end up getting 3X. I combine here and here as well. That's negative 3 is equal to 12. Add 3, I end up getting 3X is equal to 15, which means X is equal to 5. Okay? Now, if I ask you what DE is, well, now you know, because what I can do here is simply just add in, substitute X for, or substitute 5 for X, right? This was X, remember, this was X plus 3. If I substitute 5 in for X, what I would get is essentially DE is equal to 8. Okay, again, DE is equal to 8. Okay, and if I'm doing 2x minus 6, again, which is EF, I'm going to do 2 times 5 minus 6. Again, 2 times 5 is 10. 10 minus 6 is 4. So EF, or you can say segment EF, is equal to 4. Okay, so those are both part of your answers. Okay, all right, what I want you to do is go ahead and do your practice problems. Okay, let's call this number 1. Let's call this number 2. I'll let you guys go ahead and do those yourselves, and then we'll go ahead and check our answers next time I see you. Okay? All right, until we meet again, I will hope you guys have a good weekend, and I'll see you next week.